Alright, for this one, it tells us to use the form r cos theta plus alpha. Now, if we expand r cos theta plus alpha, we already know we get r cos theta cos alpha minus r sine theta sine alpha. Alright, and we're going to compare it to this expression here. Now, this expression looks a little weird because it hasn't been expanded. It's got a compound angle in it. So if I have a look at it just as is, or let's just look at that bit there. So that bit would be 2 cos theta cos pi on 3 minus 2 cos sine theta sine pi on 3. And so pi on 3 is 60 degrees. So here we're going to have cos 60, and here we're going to have sine 60. So sine 60 is root 3 on 2. Cos 60 is a half. Yep. So and a half of 2 is 1. So if I put that all together with the original 2 cos theta, so I'm now going to get, I'll write it over here first, 2 cos theta, and I've also got 1 cos theta coming from here, and I've also got root 3 on 2 times 2 is root 3, so minus root 3 sine theta. So if I put all the cos thetas together, and I'm going to put it under here, I've got 3 cos theta minus root 3 sine theta. So when I compare, if you think about it, so 3 has to be r cos alpha, and root 3 will have to be r sine alpha. So r sine alpha is root 3, and r cos alpha is 3. So if I do the first divided by the second, I'll get 10 alpha, which is root 3 on 3, which is the same as 1 on root 3. Root 3 on 3, 1 on root 3. And we know that that is our 30 degrees, so our pi on 6 in radians. And, I mean, it does say in this question we want alpha between 0 and pi on 2, so we're all good there. For r, remember we could square each of these equations and add them together, because we'll get sine squared plus cos squared equals 1. Or you can just look at the coefficients. Actually, let's just, so we've got here 3 and root 3. So if I square those, I get a 9 and a 3, which is a 12. And the square root of 12 is, because 12 is 4 3s, is 2 root 3. So I know straight away I'm dealing with 2 root 3 cos of theta plus alpha, where alpha is pi on 6. Alright, so I'm just going to go straight on to the second part of the question. So hence or otherwise solve where this equals 3. And we're doing it between 0 and 2 pi. So yes, we can just quickly simplify. So 3 over 2 root 3. So again, 3 over root 3 is 1 on root 3. So we're going to get root 3 on 2. Did I just say that incorrectly? Probably. Alright, so let me do it slowly. Alright, so if I rationalize that denominator, you would see that this would give me a 3, so I'll cancel that with a 3, and I just get root 3 on 2. Now, you are used to inverse cos of root 3 on 2, I think. That would be our 30 degrees, so our pi on 6. So we are going to get a pi on 6 as our first angle. What we have to think of, though, remember, sorry, never have enough room. So don't forget that we've been told theta is between 0 and 2 pi. So therefore, if I'm solving for theta plus pi on 6, I'm going to go from, I'm going to add pi on 6 to 0 and to 2 pi. 2 pi being 12 pi on 6, right? So if I add pi on 6 to that, I'm getting 13 pi on 6. If you think about it, we're just going from pi on 6 all the way back around to there, so 13 pi on 6. And if we look back here, we've got cos of an angle equals a positive. So that is going to be both in this quadrant here and this quadrant here. And we're starting from pi on 6. So pi on 6 would be the first one. If I go all the way around to the fourth quadrant, I'm going to have, so the fourth quadrant is 2 pi, so 12 pi on 6, and I'm going to minus pi on 6. And if I keep going again into the next quadrant, I'm adding 2 pi to this pi on 6. So I'm really doing 2 pi plus pi on 6. All right, that gets me back in here, or right on here. So if I just move it up a tiny bit, so really I've got a pi on 6, I've got 11 pi on 6, and I've got 13 pi on 6. And what I'm doing now to find theta is subtracting pi on 6, so that'll give me a 0, that'll give me a 10 pi on 6, which is the same as 5 pi on 3. This will give me a 12 pi on 6, which is the same as 2 pi. And if I just check, are those in the original 0 to 2 pi, which is our original limits? Yes, our answers are between 0 and 2 pi. So we're okay, 0, 5 pi on 3 and 2 pi. So it's pretty common for people to miss out the third answer in that case, so be really careful.